Hello everyone. As we said in the last session, we are going to demonstrate Azure Machine Learning Studio, and we are going to see how we can create a model without coding. So this is Azure Machine Learning Studio. As you can see, it is consisted of different modules. Each and every block here, we call it a module, and all of these modules, we can get it from this menu. So here in each and every section, we have subsections, as you can see. And all what I need to do, for example, if I want to clean my data and I want to add, for example, clean missing data, so all what I need to do is to drag this module, and after that I can just connect it with another module in this way. So it is very easy. So AI development process is one of the topics which we have covered, and we are going to see how we can apply it using Azure Machine Learning Studio. So the first thing we need to do is we need to understand what is the objective. So the objective of our model, which we are going to create by Azure Machine Learning Studio, is a bank loan problem. So the same problem which we were always focusing on, we are going to create it here by Azure Machine Learning Studio. Let us assume that this one is already done. The second part is collecting the data. So I have already a sample data. So here what we have at the top, we have loan bank prediction data, which is .csv. So it is in CSV format. If I want to see the data, so this is the data which I have uploaded already in Azure. This data is having 13 columns and 614 rows. Of course, 600 rows is not enough to train a model, AI model, but this is just an example, just to see how we can create a model using Azure Machine Learning Studio. So here we have different kind of columns. So here we can know the gender of the applicant, we can know if he is married or not, dependents, the education level, etc., etc. And on the last column, we have the loan status. So in the loan status, I have Y and I have N. And as we said before, if we want to create an AI model for bank loan problem, we need to use a supervised classification algorithm. Why? Because the output column here is categorical, discrete value. So here we have Y and we have N. Y means this applicant is loan is approved, and N means it's not approved, it's rejected. And every time I'm clicking on any column, I can see here some statistics. For people who know how this need to be done in programming, each and every step I'm doing, it need to be done by coding. But here you have everything. The moment you upload your data, you have everything in front of you. So here you have the statistics. We can see here in the gender column how many applicants we have from both gender, male and female. So here we have the unique value is 2. Why? Because here in this column we have only male and female. And the missing value here we have 13. So in this column we have 13 different cells which are without value, which are empty. So we need to see how we can deal with it later. And then we have the feature type. So it is a string. If we will go down, we can see them statistics and graphs. So here we can see that most of the applicants, they are male, and we have few female, and we have null. Null is because what? Because of this 13 missing value, right? So like this, we can go and we can study each and every column to understand what kind of data we are going to deal with. So after uploading the data and after understanding the structure and the columns and the data type, everything about our data, we can go to the next step and try to understand how we are going to clean the data, which is very important. We need to clean the data from many things, from missing values, from the outliers, from the duplicate rows. So here, let's go back. This is the clean missing data module, which we can use. And here, if we will click on it, we can see here some settings. The settings here, we have different options. We can replace the missing data with a mean value, or with median, or with mode, same thing, whatever we have explained before. Or maybe we can remove the entire column, we can remove the entire row. So all of these options are available here. All what I need to do is to click on whatever I want to apply. And after that, after I clean my data, we will go to the fourth part, which is insight on data. So here we have select columns in datasets. So here I can filter and I can remove whatever columns I feel it is not going to add value for taking a decision. So I have removed some of the columns. I was having 13, now I have 12. So the column which we have removed, it was loan ID column. So I have removed loan ID column because it's not going to add value while I am going to decide whether to approve or reject. And then after that, what we need to do, we need to split the data into two parts. And one part of the data, which will have 70% of the rows, we'll call it training data. And the other one, which will have 30% of the data, we will call it testing data. And this is here can be done easily by split data. Split data module, which we have dragged it from here. And then we can just apply the ratio. So if I want to divide my data, my 600 rows into 70% as a ratio, here I need to write 0.7. And many other things which I will not explain it here now in detail. This is just a demonstration. So here, why here we have two terminals for this module while the others was having only one terminal, is because the output actually of this module is two things. It is testing data and training data. Number one here will be the training data, and number two here, or the second terminal, will be the testing data. And even I can see that here we have 492, so it was having 600 plus. Now it is 492. That means this is the training data, which is having 80% of the data. And the second one is what? The second one is the testing data, which will have 20%. So yes, it's having 122. While the number of column is still the same. And then after splitting the data, what we need to do is we need to apply, or we need to feed the training data into machine learning algorithm. So since it is a classification, problem, so we are going to use supervised classification algorithm. One of the algorithms which we have discussed or which we have mentioned is logistic regression, decision tree, random forest. So here what I'm doing, I'm using logistic regression as an example, but you can use any algorithm you want. And then after that, I will use this module to connect the algorithm with the training data. So I'm going to feed the training data with the algorithm using the train model. So the train model having two terminals. One terminal will be for the algorithm. The second terminal will be for the data itself. And then after that, the module will learn how to start predicting. And then after that, we are going to test the data by the testing data. So we will feed this 30% of the data now to our model, which is created now. So to do that, we need the score model. The score model is also having two input. One input will be for the model, which we have created, and the second input will be for the testing data, because now we need to evaluate our model and we need to see if the model is giving us the right prediction or not. And then after that, if we are going to see here the output of this module, the output of this module, actually here we have loan status and we have scored labels. Loan status, it is the actual Y. So what we said here, by feeding the testing data, the model will start predicting. This predicted value by the model, we will call it what? We will call it Y hat. And the original value, which was in our data, we call it Y. So what we will do is, we are going to compare the predicted value, predicted decision by the module with the original value available in our data. If they are similar, that means the accuracy is high. If they are not, that means the accuracy is low. So here what we can do is we can see if there is any difference in terms of decision between the predicted Y and the original Y, between Y hat and the actual Y. So loan status here, this is the actual Y, scored label is the predicted Y. And as you can see here, everything is same, but here, yes, we have a difference. So this is actually a wrong decision by our model. This one is okay, this one is okay. Here also we have a mistake. If we have millions or thousands of rows, can we go and check manually? Of course no. What we need to do, we need a way which will give us the summary or the report for our model performance. For that, we use this module, which we call it evaluate model. If we will see the output, here we will have a ready report, and from this ready report we can understand what is happening. So the accuracy here is what? 0.83, means it is 83 or 84, almost 84%. That means our model is taking a decisions and the accuracy is 84%. Now it depends on the business owner if they will accept this kind of accuracy or maybe they will need to enhance it, or maybe we need to add more data. Don't forget that our number of rows, it was only 600. If we will have thousands, if we will have 1 million, if we will have half millions number of rows, of course the accuracy will be very high. So 600 is not enough, of course. So, but with that, we were able to reach to this level of accuracy, 84%, which is good. Is there any way to improve it? Yes, maybe we can change the algorithm. Maybe we can see if we can clean our data much better. This is the initial result, but we are not limited to this result. There are many things we can do to enhance from this accuracy. And then after creating the model, we can deploy the model in different way. If you have your application and you want to link it with this model, which we have created it, we can do that. If you want to link this model with Excel, we can do that. All of this information we discuss in the Azure Machine Learning Studio training. So if you are more interested to go and learn about how to apply and how to create AI module using Azure Machine Learning Studio, please go and register on Azure Machine Learning Studio training. That was the demonstration. Thanks for watching.